Here we have two threads and a Boolean value stored in memory. Assuming that this Boolean is being accessed by both threads, the CPU does something remarkable. It keeps a copy of this value in a cache so that during execution, both threads can quickly access it there, instead of having to retrieve it from memory. However, this approach, while efficient, also has a significant downside. Imagine thread A updates the Boolean value to true, intending to signal thread B to perform a specific action. In the meantime, thread B continues to access the Boolean value from its local cache, which still holds the value of false. As a result, thread B might miss the signal from thread A and continue operating under the outdated assumption that the Boolean is still false. It follows that when each thread has its own cached copy of the variable, there is a high risk that they might not be seeing the most up-to-date value, and this scenario is what we call a data race. Data race scenarios can cause a lot of bugs, so let's have a look right now. You can start by downloading the course materials by following the GitHub link inside of the video's description. Once you download the zip file, extract the contents of your zip and load the Data Race Starter project onto your preferred IDE. Let's go ahead and open up the starter code. Here we have a writer thread that sets a flag equal to true and a reader thread that keeps running so long as the flag is false. So the reader thread is going to start executing first, and then after 100 milliseconds, the writer thread is going to start executing as well. If we execute this code, we can see that even after the writer thread set the flag to true, the reader thread is still running forever. It runs forever because flag is a shared Boolean variable between both the writer thread and the reader thread. The writer thread sets flag to true and then prints a message. However, this update is only visible inside of the writer thread's local cache, and the reader thread still thinks that the value itself is false. So what I can do is go back and declare this variable as volatile. This ensures that any changes made to the flag by one thread are immediately visible to the other thread. So if I rerun the code now, it fixes the data race. How did it really do that? Well, it's simple. With flag now declared as volatile, any write to it by the writer thread is immediately written to the main memory, and any read of it by the reader thread is done directly from the main memory as well. This ensures that both threads always see the most recent value of flag. It follows that when multithreading, volatile increases the visibility of a resource. So data race bugs are very common when writing multi-threaded applications. If there's ever a shared resource between two or more threads, make sure that it can be reliably accessed or modified by every thread.